Hi, I'm Bradley Sliedrecht with Venter Cranes. Today we're focusing on electrical and safety devices, specifically limit switches and controls. These are the systems that prevent overwind, rope slack, collisions and accidents. When they fail or are bypassed, the results can be catastrophic. So according to CSA B167 and ASME B30, every hoist or overhead hoist must be equipped with an upper hoist limit to stop the hook block before it collides with the rope drum, a lower hoist limit to prevent the rope from paying out too far and causing slack or bird caging, travel limits on the bridge and trolley motions to prevent end-stop collisions. You might have seen something similar to this switch, right? Usually these are used, rotary switches are used for travel limits on trolley or bridge. This one the rods just aren't installed, but generally that's what they look like. An emergency stop that instantly cuts out all power. So on your pendant you'll see a little red button, a mushroom head, your emergency stop, or if you have a remote control, it'll be a red mushroom on your remote control. And in many cases an overload limit or rated capacity limiter to prevent lifting loads beyond design capacity. Hoists like R&M and Kone, many of those type of hoists come out with load limiters built into them. There's a lot of the older hoists that don't have any load limiters built into them, and when you do find them, they've been installed after the fact as a wire rope limit. They're costly, so many customers won't purchase and install them on their equipment, but those type of things prevent overcapacity lift, right? They prevent you from damaging your equipment, and they limit the operator to the load that the crane can safely lift, right? So these others that I've mentioned here, they're not optional, they're mandatory safety devices, right? Limit switches are typically mechanical or rotary cam switches that can change states when the hook block or drum reaches a preset position. On Demag DH hoists, a gear limit switch controls S1 emergency, the S2 the operating limits at the top, and S3 the emergency, and S4 operating limits at the bottom, right? These cams are set to the emergency cutouts, so they always engage before the hook collides with the drum or the rope and reels completely, right? What you'll find is if there's no top limit, obviously your bottom block will hit the hoist, right? And if the operator doesn't notice it, you can snap your rope. And the other way, going down, if you have no down limit, we've gone out on many calls over the years where the operator wasn't watching, there was no down limit, and the hoist started reeling the rope up back the other way, right? Inevitably the rope needs to be replaced. Worst case scenario, it wraps back up the other way, and they keep working that way and they don't notice that it's backwards, right? Up's down, down's up, believe it or not, nobody notices. Or they keep holding the button, walking because they're not watching, and it wraps down, unspools and wraps up the other way, hits the top, and rope snaps. All these cases, I've seen them in the years, we've seen them here, even with the staff we have now, right? On R&M Spacemaster, like the SX hoists, even the Kone, the CXTs, a rotary limit switch is built in. The default contacts in those are S2 upper stop, right? S3 upper slow down, S4 would be your lower stop, S1 phase supervision, right? Or secondary safety. Street ZX hoists include an ultimate limit switch, a mechanical final cutoff that only trips if the electrical upper limit fails, right? This protects the rope from overwind and the block from slamming into the drum. Often the ultimate limit switch would be a hanging dead weight on the hoist, but not always. Sometimes the rotary switch is built in with an up limit and an ultimate limit, right? So be aware that there's different types. Condra, Shawbox, Kone, GH, and many others, they all use similar designs, right? Typically dual cam or rotary switches with mechanical overrides as backup, right? Like the mechanical hanging limit, etc. Sometimes you'll see just a regular striker switch with a longer rod, and the bottom block will hit that, lift it up, and that's like your ultimate limit now, right? If a limit switch fails, like I said, the consequences can be severe, right? If the upper limit fails, the rope overwinds on the drum, crushing strands, deforming terminations, or snapping the rope. The hook block can collide with the drum, causing catastrophic rope damage. And even destroying your bottom block, right? We've seen them when the bottom block hits the bottom of the drum, it damages the drum as well as cracks the sheaves and breaks the bottom block, right? So, I mean, in that case, it's worst case. Once your drum's cracked or broken, or you flattened out your grooves where your rope runs in, you got problems, right? If the low limit fails, the rope can unreel too far, causing slack in birdcaging when rewound, right? So this weakens the rope and may lead to sudden failure under load, right? This is like a minimum case. Worst case is, as I explained earlier, that it backs up and runs up again while they're still holding down, right? So if travel limits fail, the crane can collide with runway end stops, damaging wheels, end trucks, or even structures, right? And if an emergency stop is bypassed or inoperative, the operator has no backup in a real emergency. I've seen an industry where the emergency stop is just a cutoff of your 110 volt through your pendant or even your radio remote. That's wrong, right? An emergency stop should drop out the main contactor, which drops out the supply voltage in the panel. So whether that's 575, 440, 220, whatever the case may be, it drops out the supply voltage to all your other contactors. That's what your emergency stop is supposed to do. So if they're not wired in right, and a contactor burns in, your hoist can still carry on going up, right? But if you have an ultimate or a mainline contactor in it and you hit the emergency stop, that contactor will drop out, and even if your hoist up, down, or travel contactor is burnt in, the crane will cut out. So that's something I recommend be looked at on cranes. I've seen many incidents over the years because the emergency stop wasn't wired in properly or wasn't functioning, right? So this is why CSA B167 emphasizes that limit switches are safety devices, not operating controls. You should never use a limit switch as your normal stop point. CSA B167 requires all safety devices to be tested during commissioning and periodically during inspections, right? So how do we do that? Well, upper and lower limits should be tested daily, right, by slowly jogging the hook into the stop positions. The switch should cut power before contact. Emergency stops must be tested at the start of every shift. Push the e-stop and confirm all motions stop instantly. Travel limits should be checked during inspections to confirm the bridge and trolley stop before the end stops, right? You don't want a crane traveling full speed into the end stops because the operator wasn't watching, right? Sometimes they get busy doing something, nobody's looking what's going on, and you slam into those end stops, right? Damaging the end stops. I've seen a crane come off the rail from hitting end stops. It just sheared the bolts right out and came off the side, right? For hoists with an ultimate limit like the Street, the ZX, remember, if it trips, it's not just a reset. It means the main upper limit has failed or is misadjusted, right? Usually when you hit your main upper limit, it'll cut your crane. It kind of works like your e-stop is supposed to work, right? So you actually need to go look what happened, right? The hoist must not return to service until the main limit is corrected. So during periodic inspections, technicians should always open and verify mechanical condition of cams, contacts, and wiring, as well as check torque on mounting screws, right? Make sure they're tight. I've seen cases where operators bypass faulty limit switches to get the job done, right? That shortcut often leads to rope damage, broken hooks, or even dropped loads. Remember, when the ultimate limit trips, it's a red flag. Something went wrong upstream. Always correct the main limit before returning to service. So here's what you as a crane owner or operator or the maintenance technician need to know, right? Your crane must have upper, lower, and travel limits and emergency stop devices, right? And they must be tested regularly. Limits are safety devices, not controls. Don't use them as your stopping point. If the ultimate limit trips, treat it like an incident. Adjust and verify the main limit before reuse. Daily tests take minutes, but prevent catastrophic failures. Right. So here at Fenter Cranes, we set, test, and maintain safety devices across Demag, R&M, Condra, Street, Shawbox, Kone, GH, and any other brand. Right. We specialize in overhead cranes. All our training videos and information, such as this video now, is available on our YouTube channel at Fenter Cranes. Please subscribe, follow, and I hope these videos have been giving you some constructive and useful safety and maintenance insights. Again, my name is Sliedrecht. I'm the president of Fenter Cranes. I've been a crane service technician since 1995, and I'll see you in the next video.